This is Madan Sir back here again with next video for you. So let's do the other, primary cell example. So the next example we have here is button cell. It's called button cell. Button cell, also called Mercury cell. Mercury cell. Now the question is, how is it made up of? So let me write. It consists of zinc mercury container as anode and mercury oxide with carbon as cathode. Right? So let me draw and help you with that. Suppose this is a mercury cell. Now this external container is made up of zinc, Hg, amalgam. You do know what amalgam is? Amalgam. And in the center you have mercuric oxide and carbon as cathode. And between them paste of potassium hydroxide and ZNO, zinc oxide, is filled. So this is what the composition is here, right? So like I said, the button cell, which is also called mercury cell, consists of a zinc mercury container as anode and mercury oxide with carbon as cathode. This is what the setup is. I'm not that much good in terms of drawing, so I've tried my way. This container is made up of mercury oxide. This container is made up of zinc and mercury amalgam. And between that there is the central part here, which is of mercury oxide and carbon, and in between that there is a paste here, and that paste is of potassium hydroxide and zinc oxide. And after that the battery is sealed, the cell is sealed. Now what happened inside? What happened, at the anode part, zinc undergo oxidation. Why? Because zinc reacts with hydroxide and converts into zinc oxide. So the oxidation number changing from 0 to +2. There, what is happening? The oxidation number is converting +2 to 0. So this is your reduction part here, and this is your oxidation part here. And after this, it produces a cell potential of 1.35 volt. 1.35 volt. So this is what the reaction is. Let me repeat back the whole thing. A button cell or mercury cell, it consists of a zinc mercury container as anode and mercury oxide with carbon as cathode. And between both, a paste of KOH and ZNO is filled. That's it. So it consists of a zinc mercury container as anode and mercury oxide with carbon as cathode, and in between these two electrodes a paste of potassium hydroxide and zinc oxide is filled, and after the paste is filled the battery is sealed. Now you have your button cell prepared. Now the question is, where these devices are used? These devices have a very smaller potential, so these are used in wrist watches and calculator, because they do not require high voltage. So these are only suitable for low voltage appliances, low voltage electronic devices. but there is an advantage also. What advantage is? It produces a constant voltage. The voltage remains constant as long as it is working. So there is no need to worry about the fluctuation of the voltage. This is what is the advantage of the mercury cell here. Let me repeat again. What reactions take place at the anode, zinc undergo oxidation, and at the cathode, mercury undergo reduction, and it produces a potential difference of 1.3 volt. So this is how I have come up to the end of the primary cell. In the very last video, I will talk to you about the secondary cell and how does the secondary cell work. What are the example? Another very important topic coming up going to be is the fuel cell, but that's going to be in the next video. So with this, in case you haven't copied, let me be aside here so that you can copy them. So I hope you can see them, you can understand them, and hopefully I have helped you with this. So with that, I must wind this video right here. I would say thanks for watching, take care, and just say God bless you. That's it.